Okay, so this is PQ question 7 from power series tutorial. Given that y equals to e power x sine x cosine x, prove that d2y dx square equals to 2 dy dx minus 5y. Okay, so if you look at this, there's a d2y, there's a dy dx, there's a 5y. Okay, so no choice, we have to differentiate. Okay, so y equals to ex sine. So we look at our function y equals to e to the power x sine x cosine x. So what there are three functions. How do we go about doing it? It's possible to simplify it, right? Actually, if you look at sine x cos x, by now if you look at sine x times cos x, sine times cos, cos times sine, what comes to your mind? Actually, you can do double angle, and you acknowledge, this is just e power x times sine 2x over 2, sine 2x over 2, right? So it's just the same as a half e to the power x sine 2x. Okay, then now what's next? Okay, we need to prove that d2y dx square equals something. So let's try. We have to differentiate. So dy dx will give us half. Okay, let's differentiate the left, keep the right. So differentiate ex, we get ex times sine 2x. Then now we differentiate the right, plus half again. This half is a constant coefficient. Keep ex, differentiate sine 2x, we have 2 cos 2x, right? 2 cos 2x, 2 cos 2x. So can we simplify this? Yes, we can. So it's just a half e to the power x sine 2x plus e power x cos 2x. Okay, then that's dy dx. So is it possible? So looking at this, right? Don't you think that it suggests that we may be doing implicit, meaning that we are trying to force our y to appear? So looking at dy dx again, okay, looking at dy dx again, what do you see? Can you see that? What do you make out of this function? What does it look like? It looks like the original y, right? So we can also rewrite this. You say dy dx is equals to half. This is the original y, half y plus e power x cos 2x. Okay, after that, next thing we have to do d2y dx square. Okay, so you can see after I put this as y, isn't it easier to differentiate? If not, if you think about it, if I'm going to do d2y dx square, if I don't put this as y, right, I need to do another difficult product rule. Okay, so it's going to be very tiring. So with this in mind, we know that dy dx is equals to half y okay, sorry, it's not half y, it's just y. Okay, just equals to y plus e to the power x cos 2x. Okay, and next, so we just find d2y dx square. D2y dx square, differentiating both sides again, differentiating y, we have dy dx. Differentiating one more time, this will just give us e power x cos 2x minus, now keep ex, and we differentiate cos 2x, that gives us a negative 2 sine 2x. Okay, next we have dy dx plus e power x cos 2x. Okay, plus 2 e power x sine 2x. That's the d2y dx square. Okay. And after, are we there yet? No, we are not quite there yet. So we need to show that d2y dx square is equal to 2 dy dx minus 5y. Okay. So what is minus 5? So let's take a look and see. This is e power x cos 2x. This is e power x. So can we see that this is actually, this looks like, this actually looks like 4y. Okay, so we have, remember, our, this looks like 4y. Okay, and this is a dy dx. What is e power x cos 2x? E power, can we say that this, so we look at this function, can we see that e power x cos 2x is equals to dy dx minus y. Okay, so this is e2x ex cos 2x is the same as dy dx minus y. Okay, and oh sorry, this is the same, this is a plus. Okay, so this should be a minus. So this should be a minus. Okay, my bad, my apologies. So with that, you have dy dx plus dy dx, you have 2 dy dx minus y minus 4y, you have minus 5y. And over on the left hand side, this is d2y dx square. You have shown that d2y dx square is 2 dy dx minus 5y. Shown. Okay. Number 4. Okay, next one. By further differentiation of this result, we need to find the Maclaurin series for y up to and including the term in x cubed. Now we already have the up to second derivative. Means having up to a second derivative means we can find f double prime 0. Okay, so the next one we need to do is we differentiate one more time. So we can find f triple prime 0. Okay, given that we have d2y dx square equals to 2 dy dx minus 5y. Okay, so we just got to differentiate one more time. Differentiating d2y dx square, we have d3y dx cube. This will be 2 dy dx square minus 5 dy dx. Okay, and after that we need to find the Maclaurin. So again, Maclaurin series for y. Recall what is Maclaurin. From level 26 is f6 xx equals to. So this is the writing this for the 1001 time. So I hope by writing it so often you can actually memorize the formula even without looking at MF26. Okay. Okay, so first let's go to find that when x equals to 0, what is y? Okay, so when x equals to 0, you know that actually just go back to the function. Yeah, so here x equals to 0, y will just be e to the power of 0, sine 0, cos 0. So once you got sine 0, you know everything is 0. So basically, when x equals 0, y equals to 0. Okay, then from this equation, okay, dy dx equals to y plus ex cos 2x. dy dx equals to y plus ex cos 2x. So if you sub x equals to 0, what do you get? So this will just be cosine 0. E power 0 will just be will be just 1. Y is just equals to 0. So 1 times cos 0, this equals to 1. Right, so dy dx equals to 0. So you have y equals to 0. You have f prime 0 equals to 1. And going on, you actually just need to sub in consistently. Okay, so d2, so the next one is to find d2y dx squared. So to find d2y squared, we just use this equation, right? So dy dx equals to 1. So 2, 1 minus 5. We know that at x equals to 0, this is 0. So d2y dx squared equals to 2. Okay. So d2y dx squared x equals 0 equals to 2. So next, d3y dx cubed. We know that this is equals to 2. This is equals to 1. So this is the same as 2 of 2 minus 5 of 1. 4 minus 5, we have negative 1. So f of triple prime 0 is equals to negative 1. With that, we need to find the Maclaurin series for y up to include x. Okay, so we are almost done. Okay, so let's this is fx equals to e x sine x cos x. Alright, and this will be equals to, so remember it's f0, so it's a 0. Okay, f0 plus f prime 0, which is 1 multiplied by x, plus 2 over f prime double prime 0, right? X squared plus the coefficient is negative 1 over 3 factorial x cubed. So remember what is here? This is your f prime 0 this is the f0, this is the, okay, over here, this is the f double prime 0, over here, this is the f triple prime 0. So all we're using is the Maclaurin expansion formula. Okay, and with that, your answer is there, your answer is shown. Okay, so the final answer will just be x plus x squared minus 1 over 6 x cubed. Okay, hence we need to deduce the, okay, so now we come to the last part of the question. We need to deduce the Maclaurin series for the function e to the power x cos 2x as far as the term in x squared, e to the power x squared. So we're thinking, hey, how do we even get here? E to the power, or where have we seen it? Okay, so the function we are going to call upon is, remember that in dy dx we were doing something like this, that d e to the power x cos 2x can be written as dy dx minus y. So that's the idea. We know that e to the power of x cos 2x can be written as dy dx minus y, right? So how do we write it? Dy dx minus y. Is there any way you can write the Maclaurin? Yes, it's possible. Okay, so we know that what is y? Our y, as we have found, is equals to 1x plus x squared minus 1 over 6x cubed. Okay, so what is dy dx and y? So we can actually just, this is the Maclaurin expression for y. Can we say that by just doing pure differentiation, dy dx will be equals to 1 plus 2x minus, okay, 3 over 6 is just half x to the power of 2. We can say this, right? Okay, so this is based on, this is the, what we call the Maclaurin expansion for dx dy. This is the Maclaurin expansion for dx dy. Sorry, for dy dx. Okay, for dy dx. And with that, we can actually sub these two into our equation. So e to the power of x cos 2x. Okay, remember we are finding the Maclaurin expansion for this. So e to the power of x cos 2x is equals to dy dx minus y. So dy dx is 1 plus 2x minus half x squared minus y. So what is y? X plus x squared minus 1 over 6 x cubed. Right? And solving this, and you can go on and do it by yourself. What you're left with is just 1 plus x minus 3 over 2 x squared. Right? It only 1 up to the term up to power 2. Okay, so this portion is quite challenging, so it'll be good to take note of this, how you actually use the Maclaurin expansion for y to deduce the Maclaurin expansion for another function. Okay, that's considering that this is dy dx minus y. We find the Maclaurin expansion for y based on this from y. Find the Maclaurin expansion for dy dx, and also find the Maclaurin expansion for y.